Okay, so let's go through this whole problem here. They give us f of x equals 8x. They want us to find a y-intercept to the tangent line where x equals k. So first off, when we do a tangent line equation, remember it looks like this: y minus f of whatever our a value is equals f prime of a times x minus a. My son Levi is watching the video in here, and he's got a little bit of stuffy nose, so you might hear in the background. Levi, you want to say hi right now?
Hi.
Okay, stay quiet. All right, so we need these three parts, okay? I'm going to do it in three colors: red, blue, and green. Green's easiest. They told us what it is. That's just a k. Okay, so I already know that my a value is just k. All right, so then we need to find the f of k. So if, let's do that in red. So they already told me that f of x equals square root 8x. So f of k would just be the square root of 8k. That's all there is to that. So that's y minus square root 8k. And now we need to do the derivative and then plug in a k and then put that here. And then we're not even anywhere near finding the y-intercept yet. All that gives us is the equation, but then we can use the equation to find the y-intercept. So if f of x equals 8x underneath the square root, I would just think of that like so. And that's like saying 1/2 8x to the negative 1/2, but then you have to times it by the 8 because it's a little chain rule. What's that like? That's like putting an 8 over 2 square root 8x or 4 over square root 8x. Okay, that's just f prime of x though. Remember they want me to plug in a k. So what's f prime of k, which is really what I want here. Essentially what I could have done is on all of these I could have just put a k here, because they're just saying instead of plugging in a number, you're plugging in a k. So I would think of this as 4 over the square root of 8k. So, all right, now if you remember y-intercept, I need to have it in this form: y equals mx plus b. Get the y-intercept. Another way you can get the y-intercept is plug a 0 in for x and solve for y. So that might make a little bit more sense if we just like plug in a 0 here and then just get y all by itself. That's our y-intercept basically. So the first thing I would do is add this square root 8k to both sides. And if this was a 0 right here, what would I have? So I would distribute this. I'm going to do it all in black now. So 4 over square root 8k times 0 is just 0. But 4 times negative k would give me negative 4k over square root 8k. That's from doing that to that. And then I have to still do plus this square root 8k. I need common denominators because this is a weird fraction going on here. So to get common denominators, I'd have to multiply this by square root 8k over square root 8k. And what does that give me? That gives me negative 4k plus 8k over the square root of 8k, which makes positive 4k over the square root of 8k. And now I need to rationalize it because I can't have square roots on the bottom. So now, once again, I'm going to multiply by square root 8k over square root 8k. And what does that give me? That gives me 4k square root 8k over 8k. That cancels out. I could cancel that out to be a 2. And so the best answer here for the y-intercept is the square root of 8k over 2. All they want you to do is be able to work this all out with a variable in there, but not treat it like a variable, treat it like a constant. And when you do that, here's what you end up with in best form. That's the best answer. So, I mean, technically we could have said like this right here was the y-intercept, right? Like that is the y-intercept. That's what you get when you plug in a 0, but we need to work it all the way down until we're left with just this. Hope that helps.